Hi there, guys. Welcome back. Well, we're about to do 2M, which is all about composite functions. And composite functions are pretty straightforward in terms of saying, let's substitute one function into another function and we get out a new function. It's pretty straightforward in the dynamics of making the new functions. But the extremely difficult thing here is when we start talking about incorporating domains and ranges, and whether or not you ultimately have a well-defined function, or whether or not you have to change the original domain in order to create a function. And yeah, that is the really tricky thing here. And I have to say that although this looks pretty innocuous, so there's a little definition. Most of us just read a little bit and then think, well, okay, let's just go to the questions. And no, in fact, you really need to read this definition well. You really need to go through a couple of examples well here as well. So they give you an example before the examples here. And I'm going to give you another example on top of that. And then this final question, example 26, is a real head scratcher. I mean, I've spent 30 minutes here just thinking, how on earth am I going to explain some of this stuff which is in here, because I think that there is a little bit of ambiguity in this question, and yeah, that will come to when we get to it. It seems easy. You seem like you can brush over it, but in fact, there's a lot to unpack here. Okay, so let's start. Let's get rid of me, and so first of all, let's have a look at this definition. Okay, it says if f and g are functions, then the notation for the composition of functions f and g is f of g of x. So that's this. Let's steal this one. We'll do that one in a bit. Okay, that's prepping, but actually let's steal this. So it's f of g of x. That's how we would read this. It looks like fog. And so, or otherwise, you can write f in brackets g of x there as well. Now, some people also write f g x. You see that one written more often than you see this, but I really like this way of writing things down. Okay, so whenever you see, start off with this thing, fog something or other, and you might not even see those brackets. You might see f g of x like this, or you might see f of g is such that it takes x to be this function over here. I don't know, maybe it's x squared plus 2. I don't know. But essentially, this is the same as this is the same as this, and this is really nice. Okay, I'm not talking about dynamics just yet. Okay, and here it says the domain of f of g is the set of all real numbers x such that x is an element of the domain of g, and g of x is an element of the domain of f. Okay, now g of x, of course, is the range of g. So what we're talking about here is putting in numbers for x which satisfy the domain of g, then getting out a range of answers, and that range of answers is now going to be the domain for f. Now, it might be that the natural domain of f is bigger than what you're putting in from g of x, but that means to say that if you're actually putting in fewer numbers from the range of x than the natural domain of x, then the range of f of x, so f of g, is going to be a subset of the range of f. Oh, that's quite a tricky concept there. What we're talking about is perhaps if we've restricted our domain to the range of g of x, then we end up restricting our range of f of x to simply a subset of the range of f, because we're restricting the domain to the answers from g of x. Right, okay. Okay, so there's a lot to think about there already. And they come up with a little example, and I like this little diagram over to the side as well. Perhaps let's just take this little diagram to begin with over here. So it says check it out, which is what we were talking about. It said we've got the domain of G, we put that through G of X, we then get the range of G, and the range of G will be the domain of f of X. Because the range is what we're going to put into the next function. So we're going to put that in. So these two things are the same. Importantly, they're the same. Okay, and then we're getting this subset of the range of f out because we've got this kind of restricted domain here because the domain is on what we're getting out from G of X. Right, okay, so now I'm saying G of X followed by f of X is exactly the same as doing f of G of X, doing it in one step. Right, okay, so there's a lot of discussion there. Let's actually look at a practical example. And the one they've got here is a good little starter. So let's take this, and it comes up with this thing at the end where it says f of g of x is well defined. We'll discuss what that means. So it says, for example, here we go, f of x is this, g of x is this. So we're looking to get f of g of x. So let's write that down. We've got f of g of x. So we're saying wherever we normally see x, we're going to replace that by g of x. Okay, so f of g of x, so g of x is actually x squared. This is the same as this thing here. Now, wherever we normally see x, we're going to replace it with x squared. So a bit like if I was going to say f of 1, that would be substituting x with 1. But in this case, we're replacing x with x squared. Okay, so let's put x squared into f then. So I see that instead of this being x, I'm now going to have x squared here. Okay, so that's pretty straightforward. That's our function. Now, let's just think about how these things are defined. And given that they've not talked about how these are defined in terms of, they've not said, okay, f of x is equal to 2x minus 1, and we're restricting this to perhaps, I don't know, between 2 and 3, for example, all the real numbers between 2 and 3. They haven't put those restrictions in, so we have to assume, if they haven't put those restrictions in, that we have the natural domain. But the natural domain of these functions is the largest possible set of numbers that you can put into them. And that's what they're talking about here. So they're saying the domain of f and g is the set of real numbers. Sure, right? I can put in anything I want in here and get an answer out. And I can put in anything I want in here and I can get an answer out. Okay, so we can say the domain of f is x belongs to all of the real numbers. And the domain of g is that x belongs to all the real numbers again, okay, because we can put anything we want into those things. Okay, all pretty straightforward so far. Now, the range of f is the set of real numbers. Okay, in other words, if we put real numbers in here, we can get any answer we choose. This is a straight line graph which goes on infinitely down and infinitely upwards. Okay, so the range of f is the set of all real numbers. Okay, the range of g is the set of all non-negative numbers. Okay, so in other words, when x is greater than or equal to 0, because we can only get positive answers out there. So nothing new just at the moment. But now it's saying the range of f of g of x is the subset of the range of f. Okay, so some things to unpick here. Question is, what is the domain of f of g of x? Well, x is allowed to be anything we want to start off with. And then from g of x, we're getting out positive answers. So in other words, the range of g is the set of non-negative numbers, so including 0. So we're putting in 0 and above into f of x, and that's allowed because f of x is defined to accept any real number. So we've now restricted the domain of f of x in this case, because we're not putting in any x, we're now putting in the set of non-negative numbers. Okay, so that's fine. We're allowed to do that. We're allowed to put the range of g into f. This is completely fine. And then the range of f of g of x is going to be restricted because we're only allowed to put in non-negative numbers. So, so the range of f of g of x is the subset. Now, however, we can Yeah, so no, that's fine. So we are now getting out a restricted range from f of g of x. In other words, it's a subset of the range of f, because remember the range of f was, so the range of f would have been to say y can be any real number, what we're getting out of that one. And you can see here that we're only getting positive numbers -1. So now we're restricting our range of f of g of x to this subset of the normal range by saying that we can only have numbers coming out which are greater than or equal to -1. Okay, right. So this is fine. This is well defined. There is no issue about the numbers that we're putting in originally. Remember, originally we're putting in numbers into g of x, which are your real numbers. That's getting restricted. We're getting a restricted range out finally. But there's nothing wrong with this. This is well defined. This is an okay composite function. Okay, so let's have a look at something which is not there. So, okay, so let's just take a little bit here so I can write on the page. So let's look at f of x is equal to 2x minus 1. And now let's define this for x belong to all our real numbers. And g of x is equal to the square root of x. And here we can see that we can only put in numbers which are greater than or equal to 0. Now let's try and make f of g of x and let's try and make it the other way around as well and see what we get. Okay, so f of g of x is saying, well, let's put in the square root of x into f. So we're getting out 2 lots of the square root of x minus 1. And the other version is g of f of x, so g of 2x minus 1, means we're putting into this g function 2x minus 1. So we're getting out the square root of 2x minus 1. Okay, so that was the easy bit. And now here comes the harder bit. Only one of these is well defined as a function. So what do we mean? So in this case, when we put in g of x, here's g of x, we already had the domain restricted to x is greater than or equal to 0. So what's coming out as the range here? Well, you can only get out positive answers or 0 here as well. If you take the square root of a positive number, you can only get a positive answer here. Okay, so we're putting in here this restricted domain. So we're only putting in non-negative numbers into f of x here. And that's fine because you're allowed to put non-negative numbers in here. So 2 lots of a non-negative number is a totally fine thing to do. -1, that's fine. We're not going to get out all of the answers possible on the y-axis here. So the range is not any possible answer. So the range is not y belongs to any real number anymore. Range is now restricted. In fact, the range here becomes greater than or equal to -1 because this could be 0 at its smallest amount. But this is well defined. It's well defined because the original domain which we put in ends up giving us a range for g of x, which is an okay domain for f of x. It's a restricted domain, but it's okay. It works. So this is good. This is a function. Now, on the other hand, for g of f of x, now when we put in any real number here, we can get out any real number we want here as well. So the range of f of x is any real number. Y belongs to any real number. Now, when we substitute any real number in here, okay, so this is what we're getting out, any real number in there, into g of x. Now we have to take the square root because that's what g of x is telling us to do. Now we have this sort of conflict because we're putting in, some of those numbers we're putting in are negative and we're not allowed to do that. So this is not a function unless we decide to restrict the original domain which we're putting in. Okay, that's quite a tricky concept, I think. And that turns up later in these questions. The key bit really is this. Let's just take this little diagram. And this is the really key thing that you need to remember, is that the range of G is the domain of F. That's when we're doing F of G of X. Okay, so what's coming out for G of X is what we're putting in for F. And that's really crucial. If we end up having a range for this which is too big, is bigger than the domain of f of x, or includes things which are not in the domain of f of x, the natural domain of f of x, then we have a conflict, and therefore we don't have a function unless we restrict the original domain. That's super important. I've labored this. I'm at about 20 minutes now on this video, and I'm really laboring this because it's super important. Okay, so let's actually have a look at one of these questions. Try and do this. So example 25. Example 25, I don't think it's too tough. Okay, so g of f of x, find this if f of x is equal to 2x minus 1 and g of x is equal to x squared. Was that not the question? Let's have a little look. 2x minus 1, g of x is equal to x squared. I think we've just done this one, right? Well, let's have a look at what they're doing. Let's actually steal their version of this. This was the original example in the chapter I already talked about. So g of f of x is basically saying, let's substitute f of x into g. Well, what is f of x? It's 2x minus 1. Let's substitute it into g. What's g asking us to do? It's asking us to square that. So let's replace x by 2x minus 1. That is super simple. By the way, it says here, let g be the argument of f. I think it's the other way around. I might be wrong, but I think that f is the argument of g. Remember, the argument is normally x. It's what you're putting in. It's the independent variable, and we're putting in f of x here. So I think f of x is the argument of g. I might be wrong, but I think that's wrong. So now we're thinking about the second part of this question here. It says state the domain and range of f, g, and g of f. Okay, so it's pretty simple to see that the natural domain, which is what they're really asking about, the natural domain of f is basically any number I choose. I can put any number I want to in that. And the natural domain for g is any number I choose as well. I can put in any positive, any negative number, any zero, that's fine. So domain for f is the real numbers. The domain for g are the real numbers again. Now, if we're talking about g of f, not f of g, the domain for f of g, oh, hang on a second, that's switching it round, isn't it? They've actually switched this around. That's a little issue there. That should say domain of g of f, because that's what they're asking us for in the question. Now, the domain of g of f is the same as your range of f. Again, what is the range of f? What is coming out from f? Any number you want. So the domain of this is any number you want. Now, actually, the domain of f of g, just out of interest, is not the same, because what's coming out of g of x is actually only the non-negative numbers, so 0 and positive numbers. So the range of this is 0 and positive numbers. So the domain of f of g of x depends on the range of g. So that would actually not be R, that would be non-negative real numbers. Okay, so that's definitely a little mistake which is in the book there. So just cross that one out. Okay, so we're good with that. And then we're talking about the range of f and g of f. Okay, so the range of f we've already talked about. We can get out any number we want. The range of g we've already talked about as well. We can get out any non-negative number. So 0 and positive numbers, what we can get out of x squared. And of g of f, okay, so for this thing here, considering that the domain of this is any real number that's going in, then the range which is coming out of this is basically any positive number. And you can see what the graph is looking like here. You can see that this is crossing at 2x minus 1 is equal to 0. It's crossing x is equal to a half here. That's when we're getting a 0 for this. We're getting this repeated root. But yeah, you can get in this graph here, which we have no restricted domain about, we've just verified that here, we can get out any positive number and 0 as well for y. We can't get out anything which is negative. Okay, let's just look at how they've written that, which they're saying the range of f is the real numbers. The range of g is, they're saying r plus union with 0. That's the same as me saying positive numbers including 0. And that's the same as what we just discussed there for r, the range of f of g. So they're saying f of g again. We weren't asked for f of g, we were asked for g of f. So again, there's a little mistake in the book there. Okay, you don't have to write this. If you don't like writing r plus and this range thing, range of g of f equals this r plus union of 0 and so on, you can actually just say, well, the range of this thing here, g of f, is such that x is greater than, not x, sorry, y is greater than or equal to 0. Okay, and you could say where y belongs to our real numbers. So that's the condition that we have there. Okay, yeah, if you wanted to, you could also say g of f of x is greater than or equal to 0 as well. I've just replaced that with y. Okay, right, that's good. That's sorted. Now let's look at the harder version for the next question, example 26, and this is the one I was really struggling with. Okay, so let's just bump this up to a maximum what I can fit on the page, and then let's take this, and I'm going to talk through this one as well. And I think there are some little issues with this, and I'll talk as I go through it. I'm just going to take a sip of my tea, otherwise it's getting cold. Right, well, let's see how long this one takes. If you want to get a cup of tea, that's perhaps a good idea because this might take 15 minutes. Okay, example 26. They've chucked in f of x, g of x, and h of x. So again, the dynamics of making these functions is really simple. Okay, so if we wanted, for example, f of g of h, no problem. Okay, we can make g of h really simply by substituting in h into g. Okay, so we'll get the square root of x plus 1, sorry, x squared minus 1. Okay, so that's really simple. And then if we want to then do f of g of h, you see they've split it up with brackets there, but what I would normally do is f of g of h of x and just work your way from the inside to the outside. Put in h of x into g of x and then come up with a formula for that, which is this, and then substitute this into 1 over x, which is giving us this thing here. So that is pretty straightforward. There's nothing difficult about the mechanics of making these composite functions. Right, okay, so let's look at the domains of these things. Now again, domains of these things here, we're talking about natural domains again, because they're not defining the domains here. So we're assuming natural domains. Well, it's easy to see that f of x can't include 0, can't divide by 0. G of x has to be all the non-negative numbers, and h of x can be anything you choose, and that's exactly what they're saying here. They're saying r can't be 0, r is the non-negative real numbers for the domain of g, and the domain of h is anything we choose. Okay, straightforward so far. Okay, right. That's going to get trickier. So for part 2, we're looking for the domain of g of h and the domain of f of g of h. Okay, so first of all, let's just think about what the natural domain of g of x should be. So the natural domain of g of x, this is g of x. And we know that putting inside the radical sign, or the square root sign, we should have numbers which are greater than or equal to 0. So that's x squared is greater than or equal to 1. And that's saying, of course, we can split that into 2 and say, well, then x is going to be greater than 1, but also x could be less than or equal to -1. Those are the two conditions. Now, that's what they talk about here, and that's the natural domain for this function here. However, this is where I think this question is a little bit ambiguous, because, of course, the definition for the domain of g of x is the range of h. Okay, what we're getting out from h is what we put into the domain of g of x, g of h. That was in this definition in the book. Let's have a look at the definition. In the middle here of this diagram, it says the range of g and the domain of f. Okay, that's that middle box. They've got to be the same. So when we're talking about the domain of g of x, g of h rather, I think that is wrong in the book. If we were talking about the natural domain for these ultimate functions, then sure, this would be true. But ultimately, we need to have the domain of h being, sorry, the range of h being the domain of g of x. Now, what is the range of h? Well, the range of h, what can you get out from this function essentially? So what can you get out from the function of h? That's this one here. What can you get out of this? You can get out y. So answers for h are greater than or equal to -1. So by putting in a 0 here, we'll get the smallest value for x squared. And so the smallest value for this entire function is -1, and everything else is going to be greater than that. Okay, now you can see that the range here is not the same as this domain here. So perhaps we need to restrict this domain. We're saying, well, okay, this is a larger set and that this is just a subset, and that's fine, of course. We can put in a subset of the domain, the natural domain, as long as it's a subset. But in fact, this isn't a subset, because this includes numbers like, for example, 0, and this doesn't include 0. So we're basically, if we follow through that, we can put anything we want into h, and we get out any numbers which are greater than or equal to -1. Well, then when we put those numbers into this function here, we'll see that when we essentially get our answers for this bit, which are greater than or equal to -1, that's what we're talking about, y is greater than or equal to -1. When we're substituting those numbers in, we realize that there's a conflict because that will include numbers like 0, which is not included in the natural domain. Phew, that one's a little tricky to explain. Okay. Right, so in fact, this is the natural domain for this function, but there's a conflict that we have. And it's a conflict in that we've got too many numbers coming into the function of g, and where's g? And g is the square root. So we've got negative numbers coming in there, which means that we're going to need to trim our original domain in order to make this a function. Okay, that's why I think there's a little ambiguity in the question. I think really it should say this should be talking about the natural domain. Okay, I think I've done that to death. Right, so for f of g of h, okay, so let's go on to f of g of h. Now, in terms of the natural domain of f of g of h, well, we can see that for f of g of h, for this one here, what are we allowed to put in for this function? Well, we've got to put positive numbers into square roots. So again, it's got to be greater than or equal to 1 or less than or equal to -1. But remember, we can't have 1 divided by 0 now as well. So you can't allow this number on the bottom to be equal to 0. So what are we talking about for x there? Well, in terms of x, that's going to be 1 squared minus 1 gives us a 0. So we're not actually allowed to have the equals to anymore. So now the domain for f of g of x by considering the original x's that we put in. The domain for this should be this. This is the natural domain considering the original x's we put in. Again, we're answering the question, what's the natural domain for this? Okay, now you can see why the question is sort of conflicted a little bit here, because in the next part it says the range of, take that back as well. So the range of f d h g of h and f of g of h. Now, okay, so the range of f and g and h are really simple, of course. So in other words, what are we getting out for f? Well, we get out any number, but we can't get out 0 because the numerator is never 0. So that's what they're saying here. All real numbers take away 0. The range for g is pretty simple as well. It's just all non-negative numbers. In other words, y is greater than or equal to 0. You can see the flick back to the notation of saying y there. Y is greater than or equal to 0. And for h, we can see that we're getting out answers which are greater than or equal to -1. It's pretty simple to see. 0 is the smallest number which you can get out here. So the smallest number in total that you can get out is -1, right? So that's all pretty straightforward. Now, the range of g of h is, of course, the numbers that you, so that is the range of g of h are the numbers that you get out of g of h of x. Okay, so that's what are you getting out from this? Now, we can only get out, and this is what we were discussing before, with the range of this should be matching up with this, and that was exactly my point from before, in fact. And so the range of this function here, g of h, is what we can get out according to putting in any number we choose. We can get out of this any number which is greater than or equal to 0. Of course, when you square something and take away 1 and then square root it, well, basically when we square root something, we're only going to get out positive answers. Now, we obviously need to restrict the domain in that case in order for that to be allowed, okay, because here we could get some negative numbers. We need to restrict the domain of this to this in order to get out this. Okay, right, so we need to have this restriction in order to get out this thing here. Okay, we can only put numbers in here which are greater than or equal to 1 or less than or equal to -1 in order to get out numbers which are non-negative to put into the square root, and out of the square root come out positive numbers. Okay, so this is the range dependent on this domain. So we've had to assume that the domain has changed. Okay, but we're basically asking, what do we get out of this function here? Well, we get out any number we choose, so long as we've defined this to be the domain. Okay, and then the range of f of g of h, again, we're saying about what numbers can we get out here? Well, again, we can't get out a 0 here, but we can get out all other positive numbers from this thing here. We're only going to get out positive numbers from the square root. We can't get a 0 because the numerator is not equal to 0. So the range of this is going to be y is greater than 0. Okay, but again, that depends on these domains that we're putting in. Now, the last part says determine whether f of g of h is a function. Okay, well, it's not, okay, because a lot of the conditions weren't met, essentially. We had numbers which we were putting into the next functions which were not working. Okay, so we started off by saying, well, we can now put in to the original function g of h, we can put in any real number. And now we're down to the end of saying, well, no, actually we need to restrict the domain to x is less than 1 and x is greater than 1 by considering this function here. So we've had to restrict the domain as we've gone through. Okay, and we've had to restrict that because when we followed through with x is greater, it belongs to the real numbers, we ended up with numbers which we couldn't put in later functions. Oh, that is hard to explain. And now I found this explanation here a little bit tricky to follow. It says the domain of f of g of h. Well, we had a problem before that. We actually had a problem with the domain of just g of h. We had a problem there. You could have talked about this. The domain of g of h was not the same as the range of h. So all of the numbers that you're getting out for h did not fit all of the numbers which you're now having to create for your domain. And we discussed that one. Now, in the answer here, they're actually going to the next part. They're saying, well, hang on, the domain of f of g of h is y, is the range of g of h. The range of g of h, given that we've accepted the mistakes from before, the range of g of h is y is greater than or equal to 0. They've said x is greater than or equal to 0 because they've changed that to the numbers that we're putting in. So we've changed from y to x, saying that we should be able to put in all numbers which are greater than or equal to 0, but however, we can find a number which doesn't fit that. So x is equal to 1 has no image. What are we talking about? We're talking about we cannot put 1 in here. And we know that because this is the natural domain. Okay, and in the range, we're getting out the fact that we can get out a 1, and yet that doesn't fit into the natural domain. Okay, so this is not a subset of the natural domain. Therefore, it is not defined as a function. Listen, I'm sorry to go on about that. I just think these are extremely tricky, these questions, and I think the question is slightly ambiguous here. I think they should really say, what is the natural domain of these things? Yeah, and the fact that they're switching from x's to y's all the time, like for example, when they change this one to this one here, is really hard to follow. Okay, but yeah, essentially remember that your range is allowed to be a subset of the natural domain of what we're going on to next. Let's just go back to this because this is the super important bit here. Okay, for something to be well defined, the range of G becomes the domain of F. Now, the natural domain of F might be bigger. That's what we said at the start. But the range of G might be smaller. But as long as the range of G is contained within, so the range of G is contained within the natural domain of F, then that's fine. And the domain of F now gets restricted to the range of G. Okay. Phew, I really went on that one. Went to town with the explanations. There's some more investigations here. There is investigation 16. So you can go that, and investigation 17 as well. I mean, these are obviously very good things to be doing. And there's your questions for 2M as well, going on to question 7. Next exercise is all about identity functions. Thank you very much for listening today. You might need to listen to that one all over again, but just take your time with these questions. Really think about what the questions are asking and realize that it may look like an innocuous exercise, but in fact, these are extremely tricky questions. The nice thing to know about these questions is that in exam situations, these questions are generally not worth that many marks. So if you're struggling with identifying the domain and range there, these are normally your real deciders for getting a level 7. Okay, well, thanks for listening. See, I've had to trim another one there. Thanks for listening to that, and I'll see you for the next one.